Okay, so this isn't really from any handout. I guess it's related to the 7.3 handout, but I haven't given that out yet. So if you want to take notes on something, you can take it right on the back of the 7.2 notes handout, or the chapter 7 part 2 handout. So in this one, we're trying to find the inverse of a log function. So in order to do that, you might remember to get an inverse. Let me switch colors here so it's easier to see what's what. To get an inverse, you want to switch x and y. Okay, so that means that the inverse is going to be x equals 1 plus log base 3 of y minus 4. Okay, well, you want to isolate the y somehow. You want to get y by itself. So first I'm going to isolate the log base 3 term. So I'm going to subtract 1 from both sides. So then we get x minus 1 equals log base 3 of y minus 4. Okay? And then it might be hard to tell, but this is actually in the conversion form. And the conversion formula is this one. Log base b of a equals c is the same thing as b to the c equals a. So remember, that's a hugely important formula. I'll make it big. Okay. And over here, if I rewrite my formula right below, the one that I have that I'm trying to solve right below here, it's log base 3 of y minus 4 equals x minus 1. So the a is y minus 4, the b is 3, and the c is x minus 1. So then when I convert it, I'm going to get b, which is 3, to the c, which is x minus 1, equals a, which is y minus 4. And then I'll isolate the y. So let me do this. This turns into, right here, this turns into 3 to the x minus 1 equals y minus 4. And then if I get the y by itself, I get 3 to the x minus 1 plus 4 equals y. And then I'll rearrange it just so y's in front. Okay, so this final thing here is an exponential, and it's the inverse of this one up at the top, which is a log. So it turns out exponentials and logs, they're actually inverses of each other. Okay. So let's come down here and we're going to try and graph the log, the same log that was in the first example. Okay. Well, in order to do that, actually, let me add a note here. So note, in order to graph y equals 1 plus log base 3 of x minus 4, we could get a table of values, a domain, a range, and an asymptote for the inverse. And the inverse is y equals 3 to the x minus 1 plus 4, because we know how to graph exponentials. And then all we need to do is switch out all the x's and y's. And that'll give us the info we want for the original. Okay? So that's the method we're going to use in this class. There are other ways of graphing logs, but I think this is going to be even though it's a long process, it's probably the easiest way of doing it for our class. So in this one, whoops, lost the parentheses. Graph y equals 1 plus log base 3 of x minus 4. Well, we already know its inverse. We just did it in the previous example. So the inverse was y equals 3 to the x minus 1 plus 4. Okay, so we're gonna get some info for this. So a table for the inverse. So I'm just gonna kind of do this. This is all for the inverse here. Okay, so the parent of the inverse is going to be y equals 3 to the x. So we'll make a chart for that, x and y. -2, -1, 0, 1, 2. And 3 to the -2 is 1/9. And 3 to the -1 is 1/3. And 3 to the 0 is 1. And then 3 and then 9. And then since it's just a parent exponential, the asymptote is y equals 0. The domain is all real numbers. And the range is everything that's positive. Y's are greater than 0. So then there's no vertical stretch because there's no number in front of the 3 here. So really all we need to do to get to the next chart is we're going to shift it right by 1 unit and up 4 units. So now our new chart is going to be for the full inverse, which is y equals 3 to the x minus 1 plus 4. And if I go right 1, then I add 1 to all my x's, so -1, 0, 1, 2, 3. And then if I add 4 to all my y's, I get 4 and 1/9, 4 and 1/3, 5, 7, and 13. And then since I had to add 4 to my y's, my new asymptote is really y equals 4. My domain, I had to add 1 to all numbers. So if I add 1 to everything, I still get everything. And then my new range, since I added 4 to the y's, it's really y is greater than 4. Okay, so I guess I didn't need to draw that big. Okay, that's for the inverse. Okay, to get the original back, I need to switch the x's and y's back. Switch x and y. Okay, so here's the table for the original. Oops, too far. X and y. Just switch all the x's and y's. And the original was y equals 1 plus log base 3 of x minus 4. So this is going to be 4 and 1/9, -1. And 4 and 1/3, 0. And 5 and 1, 7 and 2, 13 and 3. The asymptote, well, I switch x's and y's. So instead of y equals 4, it's x equals 4. Domain deals with x's. So if x's are all real numbers in the inverse, then the range means all the y's are all real numbers now. Okay, and here I had y is greater than 4. So if I switch that out for x, it becomes the domain. X is greater than 4. So here's the info we need to graph a log, right? To graph that log that we started with. So let's go ahead and graph it. So let's see, we got a lot of positive x's and mostly positive y's. So I'll graph it like this. The x's go all the way out to 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the y's go up 3. So I'll go 4, and then down -1. And then let's graph the asymptote first. So x equals 4, that's a vertical line. So it looks like this. X equals 4. And then we can plot our points. So x is a little more than 4 and y is -1. A little more than 4, y is -1. When y is a little bit more than that, but still just barely bigger than 4, y is 0. When x is 5, y is 1. When x is 7, y is 2. When x is 13, y is 3. And so this graph looks like this. Just like that. Okay? Kind of looks like an exponential, but sideways, right? And so that's what logarithmic graphs look like. So this process is outlined for you if you go to, let me see if I can find it here. Important ideas. Okay, this is on the important ideas PDF that I've been attaching to homework. This is how you graph an exponential. And if you scroll all the way down to page 2, way down at the bottom here, I've outlined how to graph a log. So, find the inverse of the original function. And here's an example worked out. Find the original. Isolate the log term, right? Rewrite an exponential form. Isolate the y term. Create a table of values and domain and range and all that stuff. And then switch the inputs and outputs, okay? So you have a reference for this, and I keep posting it online with each new homework. And if you don't have a hard copy of it, come find me. I'll give you a hard copy of the important ideas handout. Okay, I hope that helps a little bit.